question was posted over a year ago, and I thought I came across it and thought I'd give it a shot. Here is the line x plus 5 equals 0, or x equals negative 5, and the line y equals negative 4, and then 2x plus y minus 10 equals 0, which you can also write this way. So it's a line with the y-intercept of 10, slope of negative 2. You can figure out the coordinates of all the vertices just by using the substitution method. This is actually a special case where we're finding these segments for a right triangle. But I thought I'd share my screen and show you the general case. So centroid of a triangle is where the medians intersect. So for any triangle ABC, if you connect each vertex with the midpoint of its opposite side, you've got a median, and all those medians intersect at a point called the centroid. It's like the balance point. If you balance that triangle on a pin at the centroid, it would balance perfectly. Okay. How about, let's see, altitudes. That's kind of a cool one. The altitudes intersect at a point called the orthocenter. And if the triangle is acute, this little green triangle is called the orthic triangle. It's the vertices are actually the points where the altitudes intersect the opposite side. And there's the altitudes all intersecting. But if you make one of the angles acute, all of a sudden the orthocenter is outside the triangle. If I extend the sides, there's all the altitudes intersecting at the orthocenter. And instead of the orthocenter being the center of this orthic circle, it's the vertex that has the obtuse angle. But if I change this back to an acute triangle, the orthocenter is actually the center of the orthic circle. Okay, there you go. Let's try perpendicular bisectors. Perpendicular bisectors of each side of the triangle meet at a point called the circumcenter. And that means the distance from the circumcenter to each vertex is identical because they all lie in the perpendicular bisectors of those sides. And so we've got what's called a circumcircle. And finally, incenter. These are angle bisectors. Each of these dashed lines is an angle bisector of the angle of a triangle. They meet at the incenter, and that's the center of the inscribed circle. Okay, so the same will hold true for this right triangle. The question is, how do you find the equations of the medians, the equations of the altitudes? Real quickly, here's what you need to know in order to find the medians. You need to know the midpoint of each side, coordinates of the vertices, the slope of the median, and then you use point slope. So for example, I won't go through every one of these. If you want the equation of median AE, that would be from, here's A, this is E down here. You want that equation? You need the slope from negative 520 to 1, negative 4. And it turns out that slope is negative 4. And then you can use point slope. Why? Well, what point should we use? Let's use E. Y minus a negative 4 equals the slope times x minus 1. If you put that in the standard form, ax plus by plus c equals 0, there's the equation. And I won't go through all the steps, but there are your three equations for the three medians. And if you wanted to actually find the centroid, you'd find the intersection of any two of those medians. Turns out the centroid here is at point negative 1, comma 4. For altitudes, you need the coordinates of each vertex because the altitude goes from a vertex perpendicular to the opposite side. So you need to know the slope of each side, then the perpendicular will be the negative reciprocal. So for these altitudes, since this is a right triangle, these are out, the legs are altitudes. But for this altitude, we need the slope of AC, which is -2. We already saw that. The perpendicular is 1/2, and so the line passes through the point -5, -4 with the slope of 1/2. There it is in point slope. Here it is in standard form. For perpendicular bisectors, you need to know the midpoint of each side, the slope of each side, the slope of the perpendicular. So again, for the line, this perpendicular bisector, the midpoint of -520, -7.4 is 1/8. The slope of this line is -2, so the slope of the perpendicular is 1/2. There's the equation. And these others are straightforward because they're perpendicular to horizontal and vertical lines. And finally, angle bisectors. These are the hardest ones. There's different ways to do this, but here's formulas for the equations of angle bisectors, given the equations of the two lines that form the angle. Problem is, you got to choose either a plus or a minus, because each two lines intersect in this acute angle or this obtuse angle. One way to do it is to decide whether to use the plus or the minus is to make sure that the constant terms are positive, and then if the angle that you're looking at contains the origin, you use the positive formula. So that's why I changed this -2x minus y plus 10 equals 0, so that if I want to find, let's see, this angle bisector right here, I'll put that equation over a square root of a squared plus b squared equals, there's the positive sign, because this angle all of these angles contain the origin. And boy, there's a complicated looking equation, but that's what it comes out to be. And similarly for the bisector of angle C, we do something very similar. For the bisector of angle B, since this is a 90-degree angle, we could just say this is a 45-degree angle and come up with the equation maybe a little differently than using this formula. But anyway, here's where the incenter is, and here's the inscribed circle. Okay, and I did this all by graphing the equations, finding the point of intersection. There you go. Hope that gave you some idea. If you happen to watch this video, if you have any comments or questions, post a comment.